Hello everyone, myself Dr. Manisha Kodape. I welcome you all for this course on oxidation reduction. This course is basically for MSc student. We know that whenever we want to synthesize any molecule successfully, we have to apply a correct oxidizing and reducing agent in order to synthesize that molecule. In this course, we are going to learn different oxidizing and reducing agents. Let us begin our course with oxidation. Oxidation is generally opposite of reduction. We'll define oxidation one by one. Addition of oxygen to the substrate. When alkene is treated with peroxy acids, we'll get epoxide. So there is an addition of oxygen to the double bond. In another way, removal of hydrogen is nothing but oxidation. One of the example, conversion of alcohol to the carbonyl compound. Here, in the secondary alcohol, there is a loss of H2 molecule which will give ketone. This dehydrogenation process is called oxidation. Then, by another way, we can also define removal of electron is an oxidation. An example is conversion of an phenoxide anion to the phenoxy radical with the loss of one electron. Oxidation also defined as when the less electronegative substituent is replaced by more electronegative atom. For example, in a toluene there are 3 hydrogens, and on substitution of hydrogens of CH3 one by one with chlorine atom finally gives the replacement of all the 3 hydrogen by 3 chlorine. This replacement of hydrogen by chlorine is again a type of oxidation. And lastly, there is increase in an oxidation number or oxidation state of an atom in a molecule or ion. So basically, we will elaborate this oxidation state in organic chemistry. So as I said previously, there is increase in the oxidation state or oxidation number of the atom. Basically that atom is a central metal atom or central atom. So if we look at this picture, on the left hand side there is most reduced molecule and on the right hand side there is most oxidized molecule. So the most reduced molecule will be having 4 hydrogens attached to a carbon, and the most oxidized one will be having a oxygens attached to the carbon. Now let us see how we can calculate the oxidation state of the central carbon or central atom. For that, consider one example which is of methanol. Now we want to calculate the oxidation state of the central atom carbon, which is always with respect to the electronegativity difference between the central carbon and the atoms which are attached to it. So carbon is more electronegative if we compare it with hydrogens. So these 3 hydrogens will contribute 3 negative charge on carbon, as carbon is more electronegative. So we have written 3 hydrogens will give you -3 charge. Now if we consider the electronegativity difference between the carbon and the oxygen is more electronegative, and that's why it will be having negative charge, and obviously the carbon will have a positive charge. So what charge is on the carbon? It is positive with respect to hydroxyl group. So as there is one OH, the charge on the carbon with respect to this OH group is +1. Now we will calculate this, the overall charge on the carbon, -3 + 1, that is equal to -2. So the oxidation state of carbon in methanol, it is -2. Let us see the another example for calculating the oxidation state. This is formaldehyde. In that we have 2 hydrogens and 1 carbonyl. So with respect to electronegativity difference, the charge on the carbon due to hydrogens, 2 hydrogens, is -2, and as the oxygen is more electronegative, it will contribute to plus charge on carbon, and as there is a double bond O, so one atom belongs to one bond. So the two bonds corresponds to the two oxygen. So the charge on the carbon due to two oxygen is plus 2. So minus 2 and plus 2, if we calculate this, it will be 0. So the oxidation state of carbon in formaldehyde is 0. Let us see the third example where it is formic acid. We have only one hydrogen, so it will contribute to minus 1 charge, and we have one oxygen in hydroxyl form, the another one is carbonyl. So total it will be 3 oxygens which will contribute to plus 3 charge, and if we calculate this minus 1 and plus 3, the total charge will be plus 2 on carbon. So the oxidation state of carbon in formic acid is plus 2. If we go from in this chain, if we go from left to right, CH4 with a minus 4 with the lowest oxidation state, and if it will be get increase in CO2, the highest oxidation state of the carbon, which is plus 4. Now let us see some of the examples where you can see the acetylene molecule, where you can see this alkyne, terminal alkyne, in that this CH3 with the 3 hydrogens contributes minus 3, and 1 hydrogen contributes minus 1 to this carbon, and 0 hydrogen will contribute to 0 oxidation state. Similarly, with respect to this carbon in alene, it is minus 2 because of presence of 2 hydrogens, then minus 2 because of the another terminal CH2 group, and in on the middle carbon it is 0 because of no hydrogen. Similarly, if you come here, it will be minus 1 for both of this carbon because of only one hydrogen, and minus 2 for the 2 hydrogens which are present on this carbon. In the similar way, you will find that in this particular alkene molecule, you have terminal CH3 group where the oxidation state is minus 3, and if we look at this terminal CH2, we have minus 2 on the carbon because of presence of 2 hydrogen, but in the middle carbon you can see it is plus 1 because the electronegativity difference of carbon and bromine is more electronegative, so it will contribute positive charge on the carbon, and that's why it is plus 1. In the similar way, you will observe here also it is minus 3, here it is 0. Now why on the epoxide carbon the middle carbon is 0? Because it will contribute, the hydrogen will contribute minus 1 and the oxygen will contribute plus 1. So minus 1 and plus 1, it becomes 0. That's why the carbon will have a 0 oxidation state. If you look at the terminal carbon, you have minus 1 because you have 2 hydrogens which will contribute to minus 2 and 1 oxygen which will contribute to plus 1. So minus 2 and plus 1 contributes minus 1. In this way, similarly, you can see here also the oxidation state of the carbon which are present in the acetone molecule.